Hello and welcome back, everyone, to our webinar series on mastering Ftrack's API. This is session 2, where we'll learn more about advanced session interaction and querying. In our previous session, just last week, we focused on more of the basics. We do have a video on demand of that if you need it. Also, the same for this session will be available once we are finished today. This is session 2 out of 5 total, where we'll be providing a demo of all that we just mentioned. My name is Michael Sears. I'm an account manager for the Americas here at Backlight. Been with the team for 3 years. Joining me once again, Seth Gibson, who's one of our solutions delivery engineers. Seth has an extensive background in game dev, real-time 3D viz, XR, pipeline dev, all sorts of stuff. So you're in very good hands. He'll be running the webinar. We expect it to last about 50 minutes, a little bit longer than last week's. We do have the Q&A panel on the bottom of your screen ready during the whole presentation. We'll try to get answers to your questions live. For any longer answers, we'll have a proper Q&A session at the end of this hour as well. So if we don't get to it, we'll get to it. And you'll also see a links section where we'll post a lot of useful stuff throughout as well, or related commentary and so on and so forth. And that does it for the preamble. Over to you, Seth, whenever you are ready. Let's get started.
Okay. Yeah, thank you very much. And again, thank you everybody for joining. As Michael said, today we are actually going to start looking at some code, and we're going to start looking at how we actually interact with our Ftrack server and with the API. So this is how you would actually change things that would show up in the web UI. That's everything from creating new entities to managing new entities. And this session is designed to kind of serve as a foundation. So you'll see a lot of the same concepts and patterns repeated, but the goal here is to get you familiar with what issuing those commands to the session looks like. So that way, in a couple of weeks, when we get into actually building triggers and actions, you'll be familiar with kind of the underlying concepts. Nothing should look too advanced or too scary. And if you want to start diving into this yourself after this session, you should be very well equipped to start issuing simple queries, simple commands through the API, or maybe writing your own test scripts. And of course, you will have access to all this code afterwards. So everything you see here is actually working valid code for the most part. So yeah, so if you're curious, if you want to get your hands dirty right away, you'll be able to do that after the session. So as we said, we are in session 2. This is session interaction and the query language. So as I mentioned, we'll actually see how to create a session object, how to interact with what we call entities, and basically just how to work with the server with the API. Again, Michael and I are here. And like Michael said, we will be answering questions, and so please feel free to toss those in the Q&A or in the chat, and we'll get to those at the end of the session. So we're going to go ahead and dive right in. The first thing we want to talk about is just some useful environment variables for setting up your dev environment. Now, there are a bunch of those that you can use, but the 3 we like to call out, and these are specific to working with the API, are Ftrack_server, which is just the URL for your server, Ftrack API key, which is your user API key, which you create from your settings, and then Ftrack API user, which is, of course, the string that you use to log in with. Now, the practical use for these is that when I create a session, I can create a session in a couple ways. One, I can actually pass in the individual parameters, so of the URL, the API key, and the user. But if I have the environment variable set, I can just call session and it will read those environment variables. And that's really useful for when you actually start to deploy your scripts. So you won't have to actually write API keys into your code, sensitive information. You can just set those environment variables on whatever your machine that's hosting your scripts, your actions and triggers, and it'll just pick those up whenever the action gets run. So that said, let's go ahead and start actually working with a session. Let's go ahead and actually look at what it looks like to work with entities through the Ftrack API. So a few interesting things to know about how the Ftrack API and how sessions work. One, everything is based off of the unit of work pattern. For you folks who aren't familiar with the unit of work pattern, what that is it's a software development pattern that you see a lot when you're working with data update objects. So repositories, databases, things like that. And essentially what that means is when you issue commands, there are ways built into the API such that commands that should logically occur next to each other happen next to each other, and when they exit, they return to you everything you need to update the data objects. So in the Ftrack API context, that means when you create an entity, for example, when you call session.create, the return value for that is everything you need to issue, as it says here, a session commit, and it will update the data object as you expect. So there's no hidden voodoo. There's nothing going on underneath. There's nothing that you have, no caveats, no gotchas, and you don't really need to understand the unit of work pattern to work with the API. I think you'll see as we get into queries that everything is fairly explanatory, but just an interesting thing. And kind of a corollary to that is, if you're curious as to kind of what's been going on, we do have a way of getting to those through a session. There's just a property on session called recorded operations. So you can grab those, you can see what's happened, what the order was and what the result of those were. Speaking of queries and caching, so queries are always issued on demand, and that's an interesting concept, and you'll see how this works later on. But you can either, when you issue a query, it's either via a session.query call, or when you retrieve an entity via a query, anytime that you access an attribute on that returned object, you're also issuing a query under the hood. So that's on demand, but it's not a query per se, in that you're saying session.query. This is something the server does, and this is where we start to get into some of the interesting kind of performance caveats with Ftrack, but we do have some ways around that, and we'll look at that as we get further into queries. And again, there is some degree of auto population. So for example, if I make a query and there's a missing data, missing value that I need for an operation, again, going back to that unit of work, the server will make sure that I have that bit of data so that the work gets completed in an expected manner. And lastly, as kind of we mentioned in the first part, everything happens locally and is cached. So once you make the initial query, everything gets cached locally, and you're not making subsequent queries to access an attribute or access an object once that's been pulled down. The last concept we want to talk about is what we call entities. You've heard me use this term entity already, and an entity is basically just what our working objects in the API are. So a task, a project, an asset build, an asset version, an asset, and these do show up in the web UI. So if you look at the web UI and you see an asset build, or you see a task, those are the same things that you're working with in the API. So there's no separation between what you're doing in the API and what's going on in the web UI. And these can be customized. They're essentially just JSON schemas that you can upload to the server. And once those are uploaded to the server, those are also accessible via the API. Those can be created through the web UI, or they can be created through the API. So if this slide looks familiar, it should, because this was the first slide we looked at. And as I mentioned, all the code we're trying to show you today is valid code. So to create a session, it's as simple as issuing a call to the session constructor, as we see here. And if you have your environment variables set, it's even simpler. So when we're working with sessions, there are a few other parameters that are very useful. So again, we've seen the first three already. If there's a case where, say, maybe you're working with multiple projects and you need to pass in those things statically, you can do that as well. Plugin paths. So this is also something you can set as an environment variable, but again, for development purposes, if you have plugins, actions, triggers living in, say, a development environment that you kind of that you don't necessarily need to provide access to all the time, you can set that specifically. And then the last two are probably the ones that you'll use quite a bit: Auto Connect, Event Hub, and Timeout. Timeout does exactly what it sounds like. It basically sets the timeout for server operations. So for example, if you're working with larger objects, larger queries, larger batches of objects, I think our default timeout is 60 seconds. You might need to increase that. And Auto Connect, Event Hub. The Event Hub is how we listen for events when we're running actions and triggers, and we'll get more into that in the next session. But basically, this provides asynchronous listening for events. So if you're running actions and triggers in your script, you'll want to create a session. You'll want to tell it to connect to the Event Hub, and then it'll just sit there and listen for any interaction from the web UI, such as right-clicking on an entity and pulling up the actions menu, or whenever something happens that's supposed to respond to an event or a trigger. So sessions do have a very defined life cycle. So as we mentioned, first of all, when you actually issue a create or a delete or something like that, you're not you're not working with the server immediately. You're working with the local cache. And when we issue a session.commit, as we see in the first line, then we propagate those changes to the server. And commit does some really neat things. For example, it validates, so you don't have to worry about bad data in your, say you did something that looked valid when something that looked valid while you were running your script, but didn't throw an error, but is not valid to the server. Commit will actually catch that, and we'll see an example of that. That sounds a little nebulous right now, but I'll show you an example of that when we actually look at our working example. Session.close, obviously when we're done, we want to make sure we close the session, because we do actually limit the number of open session connections you can have to the server. I don't know of any cases where anybody's actually run up against that, so it's not something you have to worry about if you have a bunch of actions and events running. But just be aware that is something you want to do at the end of all your scripts. Session.rollback. So this one's really interesting. This one's a special case, but it's good to have, because as you can probably guess from the name rollback, it takes all the local values and reverts it back to the last known good state. So for example, if you say you try to make a commit, you get like a validation error, or you get a missing key error, the server actually won't let you commit that, but it will stay in the local cache. So you want to actually issue a rollback to make sure that you're not continuing to put things in the cache on top of that bad state. And then the last two, session.reset and session.cache.clear, these are mainly for performance. As you start to work with larger and larger queries and databases, as you can imagine, the cache gets pretty full, and it starts taking a little bit longer and longer to do those cache lookups. So if you get to a point where, say, you're batch creating thousands of entities, every so often you can call a reset or a cache clear just to make sure that those cache lookups stay snappy and that we're not dragging performance down. So cool. Now let's get to the meat and potatoes, which is actually working with entities. And this is where we'll talk about how to create, how to delete, how to update, and basically just the basics of working with our Ftrack objects. So as we mentioned, you've heard me kind of mention some of these commands already, but creating an entity is as simple as issuing a session.create. And you will pass in a key for the entity that you want to create. Now, if you're wondering what key to pass into a session.create or any query, if we go to our Ftrack API schema reference, which we can get to from our settings, you'll notice that any of these entity names here in the list, this is the actual key that you'll use, with the proper capitalization. So if you're ever in doubt, just come to the API schema reference and you'll see exactly what you need to, what key you need to use to create or access an entity otherwise. And entities can also be created with basically with a dictionary that will pre-populate the attributes. So here we are creating a task with a name and a description. And then of course we want to call a commit afterwards just to make sure that gets pushed to the server. Now, deleting an entity, just as easy. We query for the actual reference to the entity that we want, and we call delete, and then of course we call commit. If we want to update, again, it's as we think of an entity for working purposes as basically a dictionary or a hashable object. So we issue a query to make sure that we get the reference to whatever it is we're trying to get. In this case, we're updating a task status, and we'll see how this works again in the actual practical example. But so we query for our status and state. We query for the task that we want to set the status and the state on, and then we set the value via the keys. And again, if you're wondering what key to look for, back to our API schema reference, you'll notice that all these properties here, these are the exact keys that you'll use when you're updating or when you're filtering for a query. So get very, very comfortable with going to the API schema reference. All right, so we've talked about queries a bit, and that's really, like I said, that's going to be most of what you do with the Ftrack API. So how does the query language work? Well, it's pretty simple. If you've ever worked with any other sort of database query languages, you'll probably be at home here. But essentially, a basic query is structured such that we pass it an entity and we pass it a list of criteria to filter against. So for example, session query, entity, criteria, value, and then of course we have other Booleans and such that we can use to to further condition our query. So in this case, that maps to this second call. So I'm looking for a task with the name of my task and the parent of my asset build and a project called my project. Very simple. So again, we saw this earlier, but essentially, but as I mentioned, we can filter with multiple using multiple criteria, and this is something you'll do quite a bit. For example, this first query where we're just saying just give me back a random task, you're probably not going to do that day to day. So that's where we start getting into filtering with criteria. So here I just want the name, but if I want to get even better, if I want to make sure, like I said, I can continue to stack different attributes and different attribute values or criteria on top of that. So as we mentioned, queries are all issued on demand, and you issue a query to the server anytime that the first time that you access an attribute on an entity. So you're probably thinking, oh, well, that could set up some performance issues. And you are correct. If you're querying for everything all the time, eventually, especially in a larger batch of objects, eventually you are going to feel that. So what we provide is a bit of functionality that we call a projection. And what a projection does is it simply lets you pass in a list of attributes that you want to pre-populate from an entity when you fetch that from the server. So again, back to the whole concept of unit of work, what this lets you do is bundle up a bunch of work into a single query, and that will return that to you. So rather than just getting a kind of a sort of a shell object that you have to query attributes for individually, you'll get back an object with the specific criteria that you've requested. And it's actually notably faster. You will if you start once you start working with projections, you'll notice that this is orders of magnitude faster than just grabbing an entity and then trying to access individual attributes. So this is something we absolutely recommend you get familiar with as you start working with larger and larger objects, larger and larger queries, and larger batches of objects. And like I said, you will absolutely notice that. So the difference between a projection and a normal query is that we use the select keyword and we pass in a list of attributes, again, going back to the list that we saw in the API schema help. So select list of attributes and then from here, from this entity call, it looks just like a normal query. So say I wanted to get a bunch of different, time logs and assets, for example, are lists. And so rather than have to grab those individually, I just want the server to give those back to me because I know I'm working with them. So I just tell the server to select time log and assets from the task and with my filtering criteria. That's pretty much all you need to know about projections, at least for basics. But again, this is a concept that we recommend you get very familiar with because I can't stress this enough, as right now I'm actually working with some very large databases. You will absolutely feel this. So make sure that you're taking advantage of these optimization functionalities. And again, one more, just simpler. It's essentially the same thing, but I can select either a single attribute or I can select multiple attributes. And again, the rest of the query language with my filtering with my criteria and my my booleans and such is still respected. So projections are really not any different than a normal query, other than you're just getting a little more specific. Okay, and so that's the basics of everything that you need to know for this first lesson, working with queries and entities. So what we're going to do in our practical example is I have a test project here, and I've got an asset build with a bunch of tasks, and I want to add a modeling task to this, but I want to automate that. Maybe I have an external sheet, some external data source that some external data source that I can use to populate this list with. So we'll start by obviously importing all the functionality we need. We create the session as we've seen, and we'll set up a couple bits of data that we're going to want to query against and create against. For example, I have my project name, which if I look at, so webinar demo VFX, I have my I have my asset build name, and I have my task name. My asset build, again, is right here, demo 3D character test. And then my task will show up beneath this. So first, I am going to grab a reference to my asset build using a query. Hopefully this looks familiar by now. So I pass in the name of my asset build and the project name just to make sure that I have that I'm getting the correct asset build. And that gives me back a reference to my asset build. Now, one of the things you'll notice is you've seen that I've been calling these helper methods first one all on my queries. The reason for that is when I make a query initially, I'm not actually getting back the proper Python object representation. What I'm getting back is one of our custom objects called a query result. And a query result is just kind of sort of a lighter reference to whatever entity that I'm querying for, mainly for performance reasons. And it looks like a list. So when you access a query result, you can index it, you can do the things you would normally do with a list. And that's something that can trip you up and this happens to me all the time. So for example, I'll issue a query like this for an asset build, and I'll leave this off, and then I'll try and access the asset build's name or the entity, some attribute on the entity, and I'll get an error because what I have is something that looks like a list instead of the actual entity. So calling something like first will actually give me back that proper Python object, and then I can interact with it as expected. In the case of a list, for example, so say I query for the list of assets on a task, I can call .all, which just gives me back a proper Python list, and we can go from there. So something to be aware of. The caveat to that is, because you're actually requesting the object, you'll notice that query takes a bit longer than just querying without one of the helper methods. And this is something that you will actually, again, you'll feel if you're querying for a large amount of objects, but you have to be getting into the thousands or 10,000s of objects before that really starts to become an issue. So, but again, it's a good practice, at least for smaller scripts and for smaller queries. So next, we're going to grab some information about the task. Now, a task requires a type, and a type is not a string. This is another thing that can trip you up a little bit. There are a lot of attributes on entities that actually require another entity and not just a string for the name. Task type, in this case, it's just called type, is one of those. So and these types, again, they're just normal entities. So we query for them as we would with any other entity. There's no gotchas, other than some of these are server specific. So for example, you might not want to filter by project because that'll give you an error since they don't really have a concept of project, which is why this query looks very simple. But again, I query that, and then I call my session create again with the key task. And I'm going to go ahead and just pre-populate that with things like the name, the type, and the parent entity that I want to live under. Right, and we're going to add some things to our tasks. Obviously, we want to add an asset. So since this is a modeling task, we'll go ahead and add an asset of type geometry. And again, asset type is another entity type. So don't make the mistake of just putting, quote, geometry here for type. You actually want to query for the type and then pass that in. And again, this looks exactly like the last one. And as we stated earlier, this is pretty much what you're going to be doing a lot of the time. You're going to be querying against asset types and specific criteria, and then you're going to be setting and creating. So if this looks kind of repetitive and a little boring, yeah, but again, at least for me, this is kind of what makes working with the Ftrack API really fun, because once you get those basic concepts down, you can really just kind of go to town and go crazy with customizing your workflows. And as we mentioned, we'll take a look at that in a couple of weeks when we look at actions and events. So lastly, we want to version our assets. So Ftrack does have a concept of asset versions. So very simply, we just create an asset version. We don't need to capture the return value of this. We just want to make sure it gets created. We pass in our asset that we created, so it has some context. We pass in the task, so it has even more context. And if we want, we can add a comment. And again, going back to that API schema reference, any of those values you can choose to be as detailed or as broad as you want to when you're creating your assets and passing in these values. So last thing we're going to do is we're going to update the status of our task. Again, status and state are objects. So we set those, so we query for those. We use our .1 to make sure that we have the instance of the actual entity and not our query result list. We set those on our task context. And when you're working with entities, think of working with a dictionary because that's part of what you're doing under the hood. So again, we just access them by keys, and then we set a value on the key. And if we've written Python code before, we're all familiar with that. So, and again, just to reiterate, all these keys are in the API schema reference. So we'll do a little bit of housekeeping. As we mentioned, there are some specific lifecycle things we want to be aware of. So in this case, we're wrapping our commit in a try except block, just because, as I said, there are things you can do locally that might look valid, but that might not be valid to the server. And I know that sounds nebulous. But we do have a specific example, and we'll show you what that looks like. So we call our commit, we try our commit. If our commit doesn't work, we go ahead and roll it back. Then we run one final commit just to make sure that everything's good and friendly, and then we close our session. So let's pop over into Visual Studio and see what that actually looks like. Okay, give me a second to share out this. All right, so here's our code, and as we mentioned, we'll make this available after the webinar, but it's essentially what we just showed here. So we're gonna go ahead and run this, and we'll take a look at one of the things I alluded to really quick. Make sure I'm in the Python version here. Okay, I am. So we'll go ahead and give this a run. Yep. And what we should get is we get this validation error. I don't know if folks can see that, but essentially what happened is I tried to pass a status to the task that is not valid for this project schema. So I tried to set work in progress on a task, and this particular project schema that I'm using doesn't allow me to do that. So as I mentioned, there are things you can do locally that look all well and good, but the server will say, hey, actually, I can't do that according to what's in my system settings. And that's another really interesting thing I should mention is, we mentioned you can create schemas, you can create whether that's an entity or a project from the web UI in the system settings, and anything you create there is actually accessible through the API. So say if somebody, you have a producer or somebody who wants to go in or a pipeline TD who wants to go in and set up your own custom entities and they want to do it through the web UI, perfectly valid. As soon as those are committed, you will have access to all those settings through the API. So let's end. Another thing to note, if I go back to my my server, my web UI, you'll notice that nothing has changed. So because we caught it, we rolled it back, and then we committed our last good state, which in this case is a match. So let's change this to something valid, like ready to start. We'll save this. We'll go ahead and run this. Okay, and if I come back to my web UI, it's here. We see that our modeling task is here. It's got our state that we set, and we're good to go. So that's essentially the basics of working with sessions and entities. And as you see, everything we do there does in fact propagate to the web UI. Everything that's in our server settings does propagate back to our API session. So it's pretty straightforward to make these changes, and it's very powerful. There's, you can go as deep or as shallow as you want. There's some fairly hacky things you can do with the API, which we don't recommend or support, but I'm not going to tell you what those are. But if that's the direction you want to go, have at. So that's pretty much all we have for this session. I'll go ahead and stop sharing, and let's take some questions. Okay, ooh. Right. How does session rollback and reset differ? That's a really good question. So rollback doesn't actually clear the cache. It just, or the local state. It just says, oh, what was the last good local state I had prior to an error getting issued? Reset actually goes in and clears, just blows everything away, scorched earth. So, if you queried for something, say you queried for a list of entities, that's gone. If you had populated stuff, that's gone. But a rollback will actually still maintain some of your cache state. So you don't have to re-query for all the things all the operations that you've done previously. That's a good question. Any other questions? Let's see. Oh, I should go to the question tab. Let's see. Is session query, that's a good question too. Wow. Is session query using the helper method of one slower than doing probably not. In fact, I would say no, because you're essentially doing the same thing. Because when you do a session query with an index, you're basically you're doing the same thing. So you're saying when you do a session query with the helper method, you're saying, hey, query result, give me the Python object for the query result. So you have to issue you have to do all the work to get that Python object. And it's the same when you're doing, if you do the index. So you're basically saying, hey, look into the query result and fetch me the actual object. So let's see. Which attributes are projected by default? Let's see where there need to write select ID from task where there are a few, a lot of the immutable ones. Oh, sorry. Yeah. Oh, sorry. But yeah, a lot of the kind of the immutable, I think things like I think probably parent is one. I think project might be another one. I'll have to look into that. I'll have to get you a full list of that. But if you don't mind either posting that in the forum, or we can get back to you with the specific answer to that list. Let's see. And lastly, I think, is there any difference in performance when I write query select? Yeah, and we did answer this as you mentioned, but again, to reiterate, when I select, I'm bundling all this work together into one query versus issuing a query for the entity and then issuing another query for the actual attribute value. And as you mentioned, as you start getting into larger and larger queries with larger and larger attribute values, so say you query for a task with a large list of assets on it, and you're querying a bunch of those tasks, you're absolutely going to want to start using projections. Do we have more questions? We've definitely got some time. So if we have more questions, please feel free to toss those at us.
It looks like the last one was the one from Arseny, but we can wait for a couple more to populate here.
Advice can you mention that one big query with meet criteria is much slower? What advice can you give? What is bad in queries? Yeah, that's a really good question. Obviously, you don't want to, don't query individually. So don't query for an entity and then query for, and then query individually for a bunch of different attribute values. Again, if you know what you're going after, select, use projections. Another thing I would say, and this isn't specific to queries, it's more life cycle management, but say you're batch creating a bunch of objects, be careful about how you're batching. So every so often, you're going to want to either issue a session cache clear or a session.reset. So for example, say you're creating 10,000 objects, maybe every 500 objects or every 100 objects or so, and this is something you'll just have to play with, you're going to want to say, hey, issue a cache clear, issue a reset, sorry, not a rollback. So that's definitely something I recommend. Another thing, let's see, there's a corollary to that. No, maybe that was what I was thinking. Yeah, so that's what I would say is bundle up queries as much as you can using projections, and be pretty judicious about your use of cache management, because like I said, you will feel that over time. Oh, another thing I would say too is as you get and I think I mentioned this, but as you're querying for larger and larger results, using the helper methods is definitely going to slow you down. Say I have a task with like, I don't know, 1,000 assets on it, and I want to query for that, and I say task, or just like assets from task all. That's going to take a lot longer than just giving me the query result and then picking out what I need individually. Um, yeah, actually, we're actually doing a bunch of performance tests right now internally, so we may or may not have more to share on performance best practices in the future.
Well, I think we might be able to go ahead and wrap it up then. If any come through in the next like 2 minutes, we'll go ahead and answer them right now. Thanks again, Seth, for presenting. This is a series of training webinars, which many of you know already. So do note that session 3 is in 2 weeks. We're taking a break for U.S. Thanksgiving, but it will be the same time, noon Eastern, on December 5th. I almost said 15th, but no, December 5th. I'd also like to remind everybody that we have a bi-weekly Ftrack advice clinic that is also hosted live by our team. That is more for general UI questions, so feel free to jump in there. I'm sending another link to that here in the global chat with everybody. And I don't see anything else filtering in, so from the whole team, once again, thanks for spending your time with us.
Real quick, just to whet everybody's appetite for 2 weeks, and as we mentioned, in 2 weeks, we're actually going to be looking at production. So we will be looking, I think we had a question on the first one about, how do you actually run an action or an event? How do you work with the Ftrack recipes repo? So we'll be taking a look at the Ftrack recipes. We'll be taking a look at some actual production analogous code. So again, like I said, we'll be getting a little bit into the weeds. So that's, if you're kind of chomping at the bit to get started with customizing your pipeline, you really don't want to miss the next one.
All right, y'all. Thanks again for joining, and we'll see you in 2 weeks. The recording will be out soon.